Alright, welcome back. I'm going to show you in this video a piece of test equipment that I designed and built. I collect a lot of EICO stuff. Let's see if I can get you some of the shots up here. That's the blue stuff, and then I have tons of these oscilloscopes. Some of them are rare, some are just average. But they all have CRTs. These are the static deflection kind. Anyway, some of them I don't know if the tubes work. So I wanted to build a tester to see if I could check out the tubes. So let's go take a look at what I built. So on the bench here, this is a 5U P1F. Now this came out of a Sencor PS63. Anyway, I wanted to use this in a oscilloscope clock, but the Sencor scope is got a fried transformer, and good luck getting one. So I decided to build this machine here and see if it'll test it. So what I've got in here, I've got a couple of, I think these are 400 volt transformers. And then I've got a couple of boards from American Wireless Association with the LR8N regulators in them. Now this one here is just a one-to-one isolation transformer, because this is for the grid and it's never going to go over 100 volts. This one's for the first anode, and then I built one for astigmatism. Some scopes you can use that. And over here for the high voltage I use a Variac, and then this is an old, I believe it's a EICO oscilloscope transformer. This puts out, I believe, about 700 volts, and then I hooked it into a microwave capacitor as a full wave or a half wave doubler. So this will put up to about 3,000 or 2,000 volts. Now for the voltage meter, I stuck in a small voltage divider here with a 100K and a 10K, and I've got the filament transformer here, but then I realized that most of the tubes that I'm trying to test are 5 volts, and this is a 12 volt center tap, so I'm still working on that. The next problem I had was all these displays that I ordered. I made sure they had a separate power supply, but when I'm powering these on, all the grounds are coming. So that's where all these wall warts came in. Each one's, I don't know, 9 to 12 volts. So each display has its own wall wart. Get kind of complicated. Anyway, so let's turn this on. So right now my grid voltage is at 39 volts. I have the astigmatism off. The first anode's at 146 volts. I've got my high voltage a little high, it's 1200. I think on the EICOs they run about 11. And because the filament transformer is not correct, I'm using my Hewlett-Packard over here dialed down to about 5 volts at half an amp. And so we'll turn the grid's green. We'll turn this down and see what we get. Oh, there's our spot. And this should do the focus down to a nice pinpoint. Okay, so one of the problems I had using this oscilloscope clock that I bought, I needed a bigger display. It worked fine on the 2-inch screen, but this is a 5-inch, and it only puts out about 400 volts on the board. So I'm going to dial this down. I'll put this on the dot and we'll see what happens. I imagine it's going to get mushy and out of focus. Okay, so it's enlarged quite a bit. Where are we at now? About 550 volts. Let's see if our, the grid cutoff is pretty sharp there. And we can turn our anode 1 down a bit, and we're at 150 volts now, 160. We'll go down some more, but I think this is going to probably drop out before it ever gets to 400 volts. So it's starting to get really dim now, and we're just under 400 volts. So if I want a nice bright display on this oscilloscope clock, I'm definitely going to need more than 400 volts. Unfortunately, the guy's rather protective of his circuit, which I don't blame him. But I'm going to see if I can splice a higher voltage in there. You know, even if I use another oscilloscope transformer and get 700 volts on the second anode, that should, you know, bump the display up quite a bit. Anyway, I didn't calculate the cost of building this thing. I mean, I got a few bucks in here and a lot of time. But I think I'm going to get quite a bit of use out of this, especially with all the CRTs I have. Now, there's only one other video on YouTube that I found where a guy set this up, and he used an EICO, was it a 1030, to generate most of his voltages, and then he had a WaveTech to generate the display. So, a point of note on this. This is an electrostatic display. I have not tried this on an inductive, like a coil type display, CRT, but it does work pretty good on a static. So keep that in mind. Anybody wants to add a video to this on if it works on inductive field coils, let me know. Thanks. Have a good one.